أعزائي طلبة وطالبات الثانوية العامة القسم العلمي رياضيات لغات، أهلا بيكم في حلقة جديدة من حلقات برنامجنا برنامج كالكولس. النهاردة إن شاء الله هنعمل ريفيجن على منهجنا ونشوف إزاي نقدر نتعامل مع نوعية الأسئلة. لو كانت نوعية الأسئلة MCQ إزاي هقدر أتعامل مع هذا النوع من الأسئلة، وإزاي أعرف أختار الاختيار الصحيح بعد ما أحل الستيبس بتاعتي وأشوف هل يا ترى أنا توصلت للحل الصحيح ولا لأ. Dear students of grade 3 secondary, welcome to our math program. Today we have calculus, revision on calculus. Number 1, if y equals sine to the power n plus 1 x, then dy dx equals what? Equals n plus 1 sine power n x, or equals n plus 1 between two brackets times y cotan x, or equals n plus 1 between two brackets times sine power n plus 1 x times cosine x, or equals between two brackets n plus 1 times y tan x. The function y equals sine power n plus 1 x is a trigonometric functions, and sine to the power n plus 1 must be derivative by the rule dy dx equals n plus 1 multiply sine to the power n, sine to the power n x times the derivative of sine x, which is cosine x. Remember that the power here is n plus 1 is constant, real number, but the variable is x. So dy dx equals n plus 1 between two brackets times y over sine x, which equals sine power nx multiply cosine x. Then dy dx equals between two brackets n plus 1 multiply y multiply cosine x over sine x equals cotan x. Then the derivative of the function y equals sine to the power n plus 1 x equals n plus 1 times y times cotan x. Then we can choose the correct answer, which is letter B. Number 2, if dy dx equals x sine x over y at any point of the points of a curve, and if this curve passes by the point 0 and 0 by the origin point, then prove that y power 2 equals 2 multiply between two brackets sine x minus x cosine x. dy dx is the first derivative of the function y with respect to the variable x, equals x sine x over y. Cross multiplication, then y dy dx equals x sine x. Now we have the derivative of the function y, but the question prove that y power 2 equals 2 sine x minus x cosine x. So we integrate both sides with respect to x. Integration y dy dx with respect to x equals integration x sine x with respect to x. What is the integration of y dy dx with respect to x? The integration of y dy dx with respect to x is y power 2 over 2. And what is the integration of x sine x? X sine x, we can use the integration by parts. The first part is x and the second part is sine x dx. The differential of x is dx and the integration of sine x dx equals negative cosine x. Then x multiply negative cosine x minus integration negative cosine x dx is the integration of x sine x dx. So y power 2 over 2 equals negative x cosine x minus integration negative cosine x, which is positive integration cosine x dx. Integration cosine x dx equals sine x plus constant c. Then y power 2 over 2 equals negative x cosine x plus sine x plus the constant c. What is the value of c, the constant c? Since the curve of the function passes by the point 0, 0, then 0 over 2 equals negative 0 cosine 0 plus sine 0 plus the constant c. Then the constant c equal 0, and the function y power 2 over 2 equals negative x cosine x plus sine x plus 0. Multiply both sides by 2, then y power 2 equals 2 multiply between two brackets sine x minus x cosine x. Number 3, if x power 2y equals ab ln x, where a and b are constant, prove that x power 2 multiply d2y dx squared plus 5x dy dx plus 4y equals 0. Now the relation x power 2y equals ab ln x. We can differentiate both sides with respect to the variable x. Then the derivative of x power 2 is 2x multiply y plus x power 2 multiply the derivative of y with respect to x, which equals dy dx. Then the derivative of x power 2 y, product of two functions, equals 2xy plus x power 2 dy dx equals the right hand side ab ln x, and a and b are two constants. Then ab times the derivative of ln x, which equals 1 over x. Now multiply both sides with by x. Then the left hand side 2x power 2y plus x power 3 dy dx equals the right hand side ab. Note that the right hand side is a constant. A times b is a constant value. Then if we differentiate both sides with respect to the variable x another time, then the derivative of 2x power 2 is 4x times y plus 2x power 2 times dy dx plus the derivative of x power 3 is 3x power 2 times dy dx plus x power 3 times the second derivative of y with respect to x, which equals d2y dx squared, equals the derivative of the right hand side, which is a multiply b, and a multiply b is a constant. Then the derivative of a times b equal 0. Now we have like terms 4xy plus 5x power 2 dy dx plus x power 3 d2y dx squared equals 0 by dividing by x. Then 4y plus 5x dy dx plus x power 2 d2y dx squared equal 0. Number 4, The figure below represents the curve f double dash x, then the inflection point is at x equals the opposite figure represent the curve of the function f double dash x. And what is the inflection point? The inflection point at x equals 0, at x equals -3, at x equals 4, at all the previous are correct. Now we have curve of f double dash x. F double dash x is positive and negative in some intervals, and f double dash x equals 0 at x equals -3 and x equals 0 and x equals 4. At x equals -3, f double dash x equals 0. At x equals 0, f double dash x equals 0. At x equals 4, f double dash x equals 0. Because the curve of f double dash x intersect x-axis at x equals -3, x equals 0, x equals 4. Now, what is the sign of f double dash x when x smaller than -3, or in the open interval -∞ and -3? From the graph, f double dash x is negative, and in the interval, open interval -3 and 0, f double dash x is positive. In the open interval 0 and 4, f double dash x is negative and positive in the open interval 4 and infinity. Now, if the sign of f double dash x is negative, then the function is convex upward. And if the sign of f double dash x is positive, then the function is convex downward. And in the open interval 0, 4, f double dash x negative, then the curve convex upward and convex downward in the open interval 4 and infinity. Then this curve has 3 inflection points when at x equals -3, at x equals 0, at x equals 4. So we can choose the correct answer, which is 0 or -3 or 4. The correct answer is all the previous, because the curve has inflection point at x equals -3, inflection point at x equals 0, and an inflection point at x equals 4. Number 5. Integration sine power 6x over cosine power 8x dx equals what? Plus c. Equals tan power 7x plus c, or equals 1 over 7 tan power 7x plus c, or equal 1 over 7 tan 7x, or equals sec power 7x. Now, the integration of sine power 6x over cosine power 6x cosine power 2x dx equals integration tan power 6x sec power 2x. Now we have a function tan x all power 6, and this function multiply the derivative of the function inside the bracket. The derivative of tan x equals sec power 2x. Then we can add 1 to the power and divide it to the new power. Then the integration equals 1 over 7 tan power 7x plus c. Then integration sine power 6x over cosine power 8x dx equals, the correct answer is 1 over 7 tan power 7x plus the constant c. Number 6. A 180 centimeter man moves far from the base of 3-meter lamppost at a rate of 1.2 meter per second. Find the rate of change of the length of the man's shadow. If the straight line passing through the highest point of the man's head and the top of the lamp inclines on the ground with an angle of measure theta degree. When the man is far from the base of the lamppost for a distance x meter, prove that x equals 6 over 5 cotan theta, then find the rate of change of theta when the man is 3.6 meter from the base of the lamppost. Now we have a man of height 180 centimeter moves far from the base of a 3-meter lamppost at a rate of 1.2 meter per second. Then the velocity of the man dx dt equals 1.2 meter per second. And what is the rate of change of the length shadow of this man, dy dt? From the similarity of the two triangles ABC and HDC, we have y over y plus x equals 1.8 over 3. Then y over y plus x equals 3 over 5. Cross multiplication, then 3y plus 3x equals 5y, then 3x equals 2y. Now we have a relation between x and y. Now, by differentiating with respect to the time t, then 3 dx dt equals 2 dy dt. We know that the velocity of the man dx dt equals 1.2, then 3 multiply 1.2 equals 2 dy dt. Then dy dt equals 3 multiply 1.2 over 2, which equals 1.8 meter per second. Then the rate of change of the length of the man's shadow equals 1.8 meter per second. Now, from the relation 3x equals 2y, y equals 3 over 2x. And we know that tan theta equals opposite over adjacent. Opposite is AB and adjacent is BC. Then tan theta equals 3 over x plus y equals 3 over x plus, what is the value of y? Y equals 3 over 2x. Then tan theta equals 6 over 5x. Cross multiplication, 5x multiply tan theta equals 6. Then x equals 6 over 5 tan theta, or x equals 6 over 5 cotan theta. Now we have the relation between x and theta. Then, by differentiating with respect to the time t, we get dx dt equals 6 over 5 is a constant, multiply the derivative of cotan theta with respect to the time t. The derivative of cotan theta equals negative cosec power 2 theta times the derivative of the angle with respect to time, which equals d theta dt. when x equal 3.6 meter, then y equals 5.4, then x plus y equals 9 meter. Now, theta equals shift tan 1 over 3. We have right angle triangle. The length of the adjacent side equals 3 and the opposite equals 1. Then the hypotenuse equals root 9 plus 1, which equals root 10. We have a relation dx dt equals 6 over 5 multiply negative cosec power 2 theta d theta. Then 1.2 times 6 over 5 multiply negative cosec power 2 theta. Cosec power 2 theta equals negative root 10 over 1 all power 2 times d theta dt. Then d theta dt equals negative 1 over 10 rad per second. If the derivative of the function y equals f of x is y dash equals between two bracket x minus 1 all power 2 multiply between two bracket x minus 2. At what values of x, if any, does the graph have a local minimum value, a local maximum value, or a point of inflection? First, we put y dash, the first derivative, equals 0. Then x minus 1 all power 2 multiply x minus 2 equals 0. Then x equal 1 or x equals 2. We draw the number line and discuss the intervals. We find that in the open interval negative infinity and 1, the function is decreasing because y dash is negative. And in the open interval 1 and 2, y dash negative, then the function is decreasing. And in the open interval 2 and infinity, y dash positive, then the function is increasing. This means that the curve has a local minimum value at x equals 2. Now, y dash equals x minus 1 all power 2 multiply x minus 1. By expanding the brackets, then y dash equal x power 3 minus 4x power 2 plus 5x minus 2. Now, what is the second derivative of this function? Y double dash equals 3x power 2 minus 8x plus 5. Put y double dash equals 0, then 3x power 2 minus 8x plus 5 equal 0. Then x equal 1 or x equals 5 over 3. In the number line, we discuss the intervals of convex up and down. In the open interval negative infinity and 1, the sign of y double dash is positive, then the function is convex downward. In the open interval 1 and 5 over 3, the sign of y double dash is negative, then the function is convex upward. And in the open interval 5 over 3 and infinity, the sign of y double dash is positive, then the function is convex downward. So, the function has an inflection point at x equal 1 because the curve before x equal 1 is convex downward and after x equals 1 is convex upward. And the curve has an inflection point at x equals 5 over 3 because the curve before 5 over 3 is convex upward and after 5 over 3 is convex downward. Number 8. Find the volume of the solid generated by resolving the region bounded by the curve y equals x power 2 and the straight line y equals square root of x, complete revolution about x axis. Now we have two curves, y1 and y2. y1 equal x bar 2 and y2 equals square root of x. To find the x coordinates of the intersection point of the two curves, put y1 equals y2. Then, since y1 equal x bar 2, then y2 equal root x bar 2 equals square root of x. Then x power 4 equals x, and x power 4 minus x equals 0. By taking x as a common factor, then x multiply x power 3 minus 1 equals 0, then x equals 0 or x equals 1. And we know that y2 bigger than y1 in the interval 0 to 1. Then the volume equals by integration from 0 to 1 to y power 2, y2 power 2 minus y1 power 2 with respect to x. V equals by integration root x all power 2 minus x power 2 all power 2 with respect to x from 0 to 1. V equals by integration between two bracket x minus x power 4 with respect to x from 0 to 1. V equals by multiply. What is the integration of x? The integration of x is x power 2 over 2 or half x power 2 minus the integration of x power 4 is 1 over 5 x power 5. The integration from 0 to 1. Now we can calculate the value of the volume. V equals by multiply between two bracket half times 1 power 2 minus 1 over 5 times 1 power 5 minus by times between two bracket half times 0 power 2 minus 1 over 5 times 0 power 5. The volume equals by times half minus 1 over 5 minus pi times 0 minus 0. Then V equals 3 over 10 by cubic unit. بكده أعزائي نكون استعرضنا مع بعض ريفيجن على موضوع الكالكولس، وعرفنا ازاي نتعامل مع نوعية الأسئلة الام سي كيو، وشوفنا ازاي بننفذ الستبس بتاعتنا في الحل زي ما نكون بنحل أي سؤال عادي، وبنبدأ بعد ما بنحل السؤال نختار الاختيار الصحيح زي ما احنا توصلنا إليه. Dear student, by this example we come to the end of our program today. Till we meet again, it's goodbye.